Hello everyone. In today's video, I'd like to look at how you can approach GMAT quant problem solving questions under the number theory topic. Just to mention, number theory is one of the most tested topic in the GMAT quant exam. And that has been, maybe it could change over time, but that has been one of the most tested questions, section rather, or topic rather, in the GMAT exam. So we'll be looking at divisibility test questions, questions that actually that GMAT-like questions on divisibility tests at various difficulty levels. So as we proceed, also get to see what do you need to know about this topic. What did you know about, let's say, that's not the concepts we're looking at. What do you need to know about the concepts? What do you need to know about the rules that will govern that question? How do you apply the concept to a question? And at the same time, also, how do you approach a question that may appear in the exam? So as we progress, we're going to look at various difficulty levels from sub 550, let's say sub 550 difficulty, 550 to 600 level difficulty, 600 to 700 level difficulty, and then 700 level and above. That's what to look at. So under these divisibility tests, how will such questions appear and what is being tested under each and every level of difficulty and how can you approach them? So we'll start with the first question. Yeah. At this point, I'd request you just to pause the video, attempt this question, then you can pause it and resume. For questions categorized as easy questions, or let's say sub 550 level difficulty questions, these are questions which don't require much application of logic or actually the concepts, but basically just a little bit of the concepts application. It should be good to be able to get the correct answer. At the same time, also, that doesn't restrict you from using other topics which are more or less viewed as broad or general. For instance, algebra, which is the best way to approach this question. So there are two ways of approaching this question. There's the algebraic approach, and there's also the plugging in numbers approach. Yeah, I know many students may choose to go the plugging in way because it's more or less an easy one, but I'd like to encourage you to try the algebraic method because it's more certain and more accurate compared to the plugging in values. It has its shortfalls, which I'll also mention as we proceed. So let's say we do have x and y, and they're both multiples, they're both divisible by 5, which means the multiples of 5. We can express this as a different form that is more determinate of the value that is divisible by 5. So in this case, we can say x, let x be equal, be let's say 5a, and y be 5b. So that if you're doing an operation to test the operations in the choices, instead of using x and y, we can use 5a and 5b. Yeah, and that will help make things easier. Just applying some algebra to this. And also 5a is divisible by 5, and 5b is also divisible by 5. And they're both different because a can be any value, b can be any value, as long as they're not identical. So in the first choice, x minus y is divisible by 5. So that means 5a minus 5b is divisible by 5. Is it true or not true? Yeah, this can be simplified to 5 into a minus b. Yeah, of course, the fact that you have 5 out here means it's divisible by 5 because you'll end up having a plus a minus b as an absolute value, not really absolute, but as a whole value, hence divisible by 5. So this is actually necessarily true on all conditions of x and y. The next one, you have xy being divisible by 25. That is 5a times 5b. That will give us 25ab. And of course, as you can see, this is divisible by 25. Yeah, it just speaks for itself. Yeah. Then you do have x plus y is divisible by 5. So you have 5a plus 5b. Yeah, being divisible by 5. This is actually 5 into a plus b. Yes, of course, the fact that you have 5 here, it's divisible by 5, definitely. So yeah, this is also absolutely true for all values of x and y. Then we do have x squared plus y squared is divisible by 5. That means 5a, all of it squared, plus 5b, all of it squared. That will give us 25a squared plus 25b squared. That is equal to 25 into a plus b, a squared plus b squared. And this is divisible by 5 as well. So this will be true for all values of x squared plus y squared. Yeah. The last option we have x plus 5 is divisible by 10. So we do have 5a plus 5b is equal to 5 into a plus b. This is not divisible by 10, as you can see. We'll have a decimal notation, and that is actually not what we're looking for. So this will not be necessarily true for all values of x and y, unless a plus b is an even number. That's then and only then will x plus y be a multiple of 10. We do be actually be divisible by 10. Nonetheless, it won't. If a plus b is an odd number, then it won't. So this is actually not true, and we have this as our answer. So this is the approach that is most advocated for, that will be most advocated for to give an accurate answer, all of them. Now let's see the plugging in method, and also we'll also see how it can work and the possible ways that it can make it work against you. So you can let x be two values, let's say multiples of 5. They could be consecutive, let's say, or even let's take x equal to 5 and y equals to 10. Yeah. Then just plug them in and see if it actually meets with the condition. Yeah, that we're looking at, for instance. The same time, we can also pick another number. Let's say this one can also be x can be 5, or even 10 can be 5 or 0. Then y can be 10 or 15 or 15. That can be. But then again, we cannot plug in the values and see. So is x minus y divisible by 5? We'll have 5 minus 10 equal to negative 5, which is divisible by 5. Then also you can have 5 minus 15. Yeah, which is equal to negative 10. Both of them are divisible by 5. So these are possible conditions that you can have. But why do we have to go through all this work? Because you have to make sure all the conditions are met. Otherwise, if you only work with one, maybe you could miss out another one and it may not work. So negative 5 and negative 10, they're both divisible by 5. So let's look at the next one. 25 xy is divisible by 25. We're looking at 5 times 10 is equal to 50. Then 5 times 15 is equal to 75. Both of them are multiples of 25. So these are possible that for any values that you do have of actually xy, it's possible that it will be, actually all those values will be divisible by 25. Yeah. So I do have these two choices being satisfactory of satisfying the condition that you do have for all cases. Because eventually the multiples of 5 end in 0 and 5. So that's what we're looking at. X plus y is divisible by 5. So looking at 5 plus 10 equal to 15, which is divisible by 5. And looking at 5 plus 15, which is equal to 20, divisible by 5. So this is also true for all conditions. Then we have x squared plus y squared, that is now 5 squared plus 10 squared, that is equal to 25 plus 100, that is 125. Yeah. Then we have 5 squared plus 15 squared. We'll have 25 plus 225, that is 250. Both are divisible by 5, so yes, for all conditions. And we have x plus y is divisible by 10. We have 5 plus 10 is equal to 15, which is not divisible by 10, but 5 plus 15 is equal to 20. So this is actually divisible by 10. So we do have actually a condition that is not necessarily true, as you can see, not necessarily true. That is what we are looking for. And therefore, this is what doesn't meet the cut and is the correct answer. So the reason why actually I do not advocate for this, because many a times students may forget to actually pick values that will satisfy all the conditions. For instance, a value that ends in both 5 and a 0 for this in this case. But what if now it's a value that is a multiple of 3 or a multiple of actually 4 something? What values will you pick? So algebra remains a more certain approach, and you should get accustomed to using it compared to plugging in numbers. I'm not saying it doesn't work, it does, but it may put you in a tricky position, or also may jeopardize your effort in an exam situation. Okay, so let's go to the next question.
You're watching Success with Bob Mwiti Show, presented to you by Appstech America. Appstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.appstechamerica.com. Appstech America will wake you up to the unlimited potential within you.
The number 123,000 y50 is a 6-digit integer, and y is a positive 1-digit integer. Which of the following cannot be a factor of 123,000 y50? So you can pause the video and attempt to approach this question, and then we can see how to approach it. So this is a question considered to be between the difficulties of 550 score to 600 difficulty. And it's asking you to find which number which will not be a factor of, which cannot be a factor of 123,000 y50, yeah, of which y is any digit between 0 and 9. So that's what it's asking you. So it has given us some numbers in the choices there, and one of them cannot be a factor of the value you have. Let's call that whole number x something, yeah. So what we need to know is how do you apply the divisibility tests of the numbers given to eliminate each and every answer except one. So that's what we need to know, and that's what we need to apply. If you don't know what the tests are, if you don't know how to apply them, then that could be a challenge to you. So in this case, we have this figure. Yeah. So 123,000, and you have y50. So from this value, if you look at it this way, just as it is, from off your head, this is an even number, so it has to be divisible by 2. It also ends in a 0, which makes it divisible by 5. But at the same time, also makes it divisible by 10. So from the choices we have, 2 and 5 will automatically be out. We don't even need to test them. Yeah. The next thing is actually to look at the divisibility tests of 3, 4, and 6. Yeah. If you can actually apply the divisibility tests and get if this value can be divisible by either of them, then we can also eliminate that number. So let's see. 1 plus 2 plus 3, that is 6. 6 plus 5 is 11. Yeah. What can be done to make this number divisible by 3? To make the units, if actually to add them to be divisible by 3, since they all sum up to 11, if y is 1, they add up to 12, and this will be divisible by 3. Hence, 3 will be a factor of the number. So with that alone, we don't even need to proceed to the next other possibilities. We just cross out 3 automatically. And the moment you have 2 and 3 as factors of a number, then 6 is automatically a factor of that number. Yeah. So that leaves you with 4. Even without testing, we're seeing that in the GMAT exam, there has to be only one answer. So even without you testing or actually checking for the divisibility of 4, you can see that 4 is the only answer. Nonetheless, should we go ahead and try and test this number? Test carry out the divisibility test for 4. We'll also see the same. This is because the divisibility test for 4 is if the last 2 digits of that whole value are divisible by 4, then that whole number is divisible by 4. So in short, if the last 2 digits are multiples of 4, is actually a multiple of 4, then that whole number is a multiple of 4. Hence 4 is a factor of that number. If you look at it, the last 2 digits are 50. For 50, what do we have? 50 actually is not a multiple of 4 because we have the number that is divisible by 4 before 50 is 48, and after 50 is 52. So you see that 50 is not divisible by 4. Hence, this value cannot be a multiple of 4. And that will be our answer right there. So as you can see for these, let me say, not so difficult questions. They just require you to know what the rules are and apply them to the question. Once you get to do that, you should be home and dry to your answer. Yeah. Okay, let's get the next question. This is now, the difficulties get higher and higher. So looking at 600, 700 level difficulty question. Yeah. The 4-digit number, 4,860x, where x is the unit digit of that number, is a multiple of 36. What is the value of x? Yeah. So you can pause this video, attempt this question, then you can see how to approach the question. And even if you get the answer correct, you can see what other options can be used, what other approaches can be used. So for questions at this level, we're mainly looking at we're looking at the application of the concepts as well as some logic, some GMAT-based logic, because GMAT is a logic-based exam. So I'm testing you how do you apply the logic. So that is what you get to see at level 600 and above. You're required to apply some logic. So in this digit of ours, 4,860x, which is a multiple of 36, we need to find what the value of x is. From the look of this value as it is, the examiners don't expect you to divide this whole number by 36 and try and find out, or plug in the values one by one to try and find out what it will be. That is of course a way, but remember you only have 2 minutes in the exam. So how would you go about this? By applying the concepts and some logic, you can get the answer in less than 2 minutes and without having to divide the whole value by adding 0, 2, 4, or by replacing x with 0, 2, 4, 6, or 8. You don't need to do that. So from the concepts of logic of multiples and digits, you may want to look at what will make this value x, this number with the value x, divisible by 36 or a multiple of 36. If it is a multiple of 36, it must have the factors of 36. That is one thing that is given. So if you actually get what the factors of 36 are, then you see what can we do to this number to make sure that it has the factors of 36 as well. Yeah. So let's see what 36 is made of in terms of prime factorization. We see it's 6 times 6 is equal to 2 squared times 3 squared. Yeah. Because 6 is 2 times 3, 2 times 3. So 2 appears twice, then 3 appears twice. So that is 2 squared times 3 squared. So what you're seeing here is that 36 must have, if you look at this is also equal to, let's say, 4 times 9. So 4 and 9 needs to be factors of 4,860x. So it's easier carrying out the divisibility test for 4 and 9 compared to trying to divide the whole of it. But both of them have to satisfy the condition for it to be divisible by 4 and 9. So let's look at this value. What values of x will make this figure divisible by 4? If actually it is 60, because 60 is a multiple of x, then you have 64, and then let's say 68. So of these 3 values, we do have them here. So we have a possible numbers that you can have. Yeah, those 3. Then now, that is now for 4. That is divisible by 4. And then let's see now which ones might make it divisible by 9. To make it divisible by 9, if you add all the digits in let's say in the value, then it adds up to a multiple of 9, then that is divisible by, that whole value is divisible by 9. So let's add the digits of this. 4 plus 8 is actually 12. 4 plus 8 plus 6. This is 14. 8 plus 6 is 14, plus 4 is 18. So as it is 18, which is a multiple of 9. So what value of x will make it a multiple of, let's say, will actually make it 9? Will make x, this whole value, what value of x will make this whole value multiple of 9? So you have actually 0. So it is also 6, 0 as one common value that you do have there. The next value would be if you add 9, because you have 18 plus 9. Yeah. So if it is 9 again, that means 69. So which means we don't have any value between 60 and 69 that could be a multiple of actually of 9. Yeah. So that is what we're saying here. And in this case, we only have one digit that is common in both of them. So that is a 0. So that eliminates those two. And we only have 0 as the correct answer. Yeah. So as you can see, it just requires a bit of application of logic and reasoning. And if you try and actually say it, this can be doable in a short time. So let's take a look at the next question. This is now 700 level difficulty question. Yeah, it's considered so, but with the knowledge of the concepts, the application, and how to approach questions, this actually, and some logic, it may not feel like it if actually you're quite good at those. So the product of the digits of the 4-digit number P is 36. No 2 digits of P are identical. How many different numbers are possible values of P? That's a question being asked. So you can go ahead and pause this video and then attempt this question. Then you can come back and pause the video and see how to approach this question. So you realize that what makes a question 700 level category is simply because it combines or it tests 2 or 3 or multiple topics or subtopics in one question. It also requires quite some logic to approach and actually be able to solve that question. And that's what makes it a bit difficult and makes it categorized that way. And ideally, the categorization is not based on only on that, but simply because not so many students get to solve them correctly. That's how it's categorized. And the reason why they can't solve it correctly is because of what I've mentioned before, what I've just mentioned. So let's see what this question tests when it comes to divisibility. So you'll find that also another subtopic is tested here, and that will makes it a bit challenging to test takers. So the product of the digits of the 4-digit number P is 36. Note digits of P are identical. How many different numbers are possible values of P? Instead of thinking in your head what values could these 4 digits be, let's call them, let's say A, B, C, D, B, C, and D. Yeah. If you multiply all these ones, you get 36. So from this, what we see is that there could be values which are factors of 36. So we could get some help by factorizing 36. So 36 is equal to 6 times 6 is equal to 2 times 3 times 2 times 3. Yeah. From here, we see that you have how many digits. Of course, another factor that you may have also, because talking about divisibility and also the 4 digits possible, there could be 1 there. That's just a possibility as well. So let's add there 1, because that will make it still 46. But also as factors of 36. So you have 1, 2, 3, 4, 5 digits. Yet that actually we see it's a 4 digit. So how do you make this sort of 5-digit representation to be a 4 digit? We have some repetition here, so we can reduce the repetitions. If you reduce them, the easiest way to reduce the repetition is by combining these two. And then if these two remain on their own, then they can still remain, can still have the values. So 2 times 3 is 6, times 2, times 3, times 1. Does this give us 36? 6 times 2 is 12. 12 times 3 is 36, times 1 is 36. And how many are they? 1, 2, 3, 4. So now we have the 4 digits that are in there, actually that make up the value, the value P, and they multiply it to 36. We've just applied some logic and just based on the concepts, prime factorization, and thinking about factors that you may have, just to make it, and also combining those factors to make it the number of digits that you do have. And you have the 4 digits being asked about. So the next thing is, how many different numbers are possible values of P? How many different numbers? In short, it can be 6,231. It can be 2,631. Yeah, 31, and so on and so forth. It can be 3,000. So we're looking at ways of writing, of representing these values of P in a way that, in how many different ways can we do that? So that takes us to the principles of counting, of counting methods. That's what it takes us to. And that's what's also something that's been tested here. So you see we have 4 digits, 1, 2, 3, 4. And they all like they either 6, 2, 3, or 1. That's what they are. In how many ways can we write these values? So by the principle, by using the principal methods of counting, you see that if actually there are 4 digits, the first position can be written in 4 different ways. Yeah, can either be a 4, it can either be a 6, a 2, 3, or 1. The second position, once the first position is taken by actually the first one, if there are 4 remaining with 3, so then the next one actually remaining with 2, and then 1. So if we multiply this will give us all the number of possible ways of writing the value P. We'll have it as 4 times 3, that is 12, times 2 times 1 is 24. Different ways. So, and that gives us choice C as the answer. And just like that, you have your question solved. Yeah. So that is how we approach that type of questions, and that is what is required for you to know, to be able to write them. And just some logic. It will take some time to think through this, maybe just to think about it, but just break it down from the known to unknown, breaking it down from 36 to prime factors. How do you get the values? Because it could be 9 times 4 or 3 times 3 times 2 times 2 again. The same, but then again, just playing the factors. How do you make these factors not identical? That's what we're looking at. So that is basically what you're looking at, and you get to solve this question. Yeah. So that's it for today. Come back again next time to see also how to approach various other questions, problem solving, data sufficiency, and also other topics, other sections in the GMAT exam. And thank you. I was a host today. My name is Joshua Buya, and welcome again.
You've been watching Success with Bob Mwiti Show, brought to you by Appstec America. Come back next time to hear more steps and missteps that I took on the path to becoming a successful immigrant in USA. Be sure to subscribe to my YouTube channel and also follow me on Facebook, Instagram, Twitter, and LinkedIn.